Okay, we're going to continue our conversation about solving equations with variables on the both sides, and we're going to start with an angle bisector problem again. And I know this is an angle bisector because it's been split into two congruent angles by this green ray. So we're going to solve for g, and to start, we're going to set up our equation. So because they're congruent, we know that this angle will be set equal to this one. So I have 3 times the difference of g and 3, or g minus 3, equals 2 times the difference of 6 and negative 2g. Okay, here I can see that I can't just start moving variables between sides or across sides. So what I want to do is I want to make sure that I simplify each side first. And by that I mean on the left side I have this 3 that I can distribute, and on the right side I have this 2 that I can distribute. And when I do that, I end up with 3g minus 9 and 12 minus 4g. All right, now we're going to return to the same exact process that we used last time, and that's where we're going to move all of our variables to the left side of the equation. Okay, so on the right side I have this minus 4g, and I want to move it to the left, so I'm going to add 4g to both sides. By doing that, I'm going to cancel that 4g out on the right side, and I'll be left with 7g on the left side. Minus 9 equals 12. And now I want to solve my two-step equation because I have two terms, 7g and negative 9 on my left side. And I'm going to use inverse operations to get rid of those two terms and be left with just g. Okay, so I'm going to start by adding my constant, my 9, to both sides. And when I do that, I'm left with 7g is equal to 21. And then I'm going to divide by 7 on both sides, and that leaves me with g is equal to 3. Let's look at one more example. And we're going to go back to our parallel lines cut by a transversal. Okay, so before we start solving or setting up our equation, I want to point out that we have two parallel lines. It's indicated by this symbol here. It's being cut by a third line, which we'll call our transversal. And I see if I look at this top intersection, this angle is located in the top right corner, the top right angle of this intersection. And this one here is also located in the top right corner. So because these are both in the same position with respect to their individual intersections, that means that they are corresponding angles and they're congruent. So I can go ahead and set these two angles congruent to each other or equal to each other. All right, I'm going to start by simplifying both sides of the equation. I'm going to follow my step 1. And to do that, I'm going to distribute my negative 5 to both parts of the polynomial and my 3 to both parts. So I have negative 5x minus 35 is equal to 9x minus 3. And now I'm going to move all of my variables to the left side of the equation. My variable right here is 9x. And to move 9x, I'm going to subtract it from both sides. That leaves me with negative 14x minus 35 is equal to negative 3. So once again, I have my two-step equation, and I'm going to start by moving my constant over. So I'm going to move minus 35 to the right by adding 35 to both sides. That leaves me with negative 14x is equal to 32. Right? To finish solving, I need to divide by my coefficient, negative 14. So I'm going to divide by negative 14 on both sides. When I divide by negative 14 on both sides, I'm left with x equals negative 3. Recall that this is therefore, so what I'm saying here is 32, I'm dividing 32 by negative 14, therefore x is equal to negative 3. And that's just because I'm now moving from left to right since I ran out of space going from top to bottom. All right, that concludes this week's notes. Thanks, guys.